Welcome to video PN17, Probability Theory, How to Divide Stakes of a Game in Progress. It's from Lesson 5, Example 14. And before I do anything, it's the first probability problem solved by Blaise Pascal, Pierre Fermat in 1654. So this is kind of where it all came from. Okay, let me get some room here. So a game is won by the first player to score 4 out of 7 points, similar to the World Series winning 4 games out of the best of 7 series. Suppose player A has 2 points and player B has 1 point. It could be like the Red Sox having won 2 games and the Cardinals having won 1 game, or something like that. The game must be suspended for some reason. Both players have equal ability, so 50-50 chance to win each game. Draw a probability tree on how the game could have finished. Find the probability that A would have won, the probability that B would have won, and then if the stakes are $10,000 for winning the whole thing, how much money should we divide between the 2 players? And that's where the problem really originated from. Okay, so just to give myself some more room, I'm going to erase this. Let's just remember A has 2 points, B has 1 point, and you got to get 4 to win. So A has 2, B has 1. Okay, so I'm going to say A, B. This has already happened. Okay? Then let's branch off. Again, remember you need 4 to win the game. 4 points to win the game. So a point, a point, a point. So I could branch off. Either A could win the next point, or B could win the next point. All right, so if I take this branch, A's only won 2, B's only won 1, so I'm going to continue to branch off. All right, over here I'm going to circle it, which means stop. A's already won 4 points. 1, 2, 3, 4. Over here, B's only won 2. I'm going to branch more. 1, 2, 3, 4 for A. That's a stopper. 1, 2, 3 for B. Let's continue on. 1, 2, 3, 4 for A. 1, 2, 3, 4 for B. So I'm circling the stoppers. All right, so likewise I'll branch here. A and B. Nobody's got 4 points yet. A and B. 1, 2, 4 for A. 1, 2, only 3 for B. 1, 2, 3, 4 for A. 1, 2, 3, 4 for B. Nobody yet. 1, 2, 3, 4 for A. 1, 2, 3, 4 for B. 1, 2, 3, 4 for B. So basically, I can say this was like game 1 or point 1, point 2, point 3, point 4, point 5, point 6, point 7. So A won after the, it's better if we did it in games, but either way. All right, so let me put the probabilities down now. They're all 0.5, so 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. If the teams were not of equal ability, let's say that one was better, like 60 to 40%, you know, to put the 0.6s and 0.4s or whatever. Okay, so that was just for the tree. Probability that A would have won. So what I gotta do is compute all the probabilities for A winning. So I've got this branch, I've got this branch, I've got this branch, I've got this branch, I've got, okay, it's going to get a little bit confusing. So people that are circled over here, 0.5 times 0.5. So for A, I've got a 0.5 squared. That's that one. This is a 0.5 cubed. I've got two of those. And this is a 0.5 to the fourth. 1, 2, 3, 4. And I've got 1, 2, 3 of those. So again, 0.5 squared is that one. 2.5 cubes, that's those two. 3.5 to the fourths, that's those three. I'll compute that later. For B, let's see what's going on with B. They've got 1 here, and that's a 0.5 cubed. 1, 2, 3. And then they've got 1, 2, 3 there, and that's a 0.5 to the fourth. So I'll compute those and then divide the stakes accordingly. Okay, so let me punch those two out. All right, so for team A first, 0.5 squared plus 2 times 0.5 raised to the third plus 3 times 0.5 raised to the fourth, and they get 0.6875. If all goes according to plan, point B's probability should add up to A's probability to be 1. Let's hope that happens. All right, for B, I'll clear this. I've got 0.5 cubed. Let me clear that. 0.5 cubed plus 3 times 0.5 to the fourth. And I get 0.3125. Those will add up to 1, so that makes sense. And then how should the stakes be divided? Well, if the game had to be stopped at this point, it only seems fair, since player A had a greater probability of winning, that he should get a greater share of the stakes. So we'll just multiply the stakes by each probability. So $10,000, that's just moving the decimal place 4 places. So 1, 2, 3, 4. So A should get $68.75, and B should get $31.25. And there you have it, how to use probability theory to divide the stakes of a game that has been interrupted.